A few days ago I finished writing a blog post on my website tutab.io where I answered the question what programming language a beginner should learn if they want to start learning to code. This blog post will also be linked in the description under this video if you want to read the whole thing. And it's segmented into different sections depending on what kind of programming you want to do. So for example, you want to build websites, you want to make games, native apps, want to get into machine learning, stuff like that. And in each section I tell you what the best starting language is in my opinion. I also created this nice overview graphic which you can also find on the blog post. And I also link to learning resources for these different languages. So I highly recommend that you check it out. And this video here will be a summary of this blog post. Now before we start, I would like to thank the sponsor of this video, which is SimpliLearn. They created this coding bootcamp in cooperation with the Caltech University. A coding bootcamp is a middle ground between self-teaching and university. You have a curriculum to follow and actual instructors that teach and help you, but it's less expensive than university, more practice-oriented and also much faster. SimpliLearn's coding bootcamp teaches you full-stack web development in 6 months, from beginner to advanced level, and they cover languages and technologies that I will also mention in this video, like Java, JavaScript, and HTML and CSS. They also teach you other important skills like Agile and Scrum and version control with Git, and they have you actually build real-world projects and deploy them to production, which is very important because you only really learn programming by building stuff. This part is often completely neglected in universities, which tend to focus only on the theory. The ratings and reviews of this bootcamp seem to be very good overall. The next cohort is starting soon. To find out more, check out the link in the description below. This video can of course only provide a guideline. Depending on what exactly you want to build, you might need a different programming language later, but those are good starting choices for beginners. And also don't overthink the choice of your first programming language. After you have learned one programming language, learning another one is usually very easy. It's not like learning a real language where learning Spanish is completely different than learning English. Most programming languages are very similar in their syntax, and learning the syntax of a programming language is not the difficult part. Learning how to think about code and how to solve problems, that's the skill. Not the syntax of the language, because you can always Google that. So don't overthink your decision, just pick something that you find interesting, start with that, and you can always switch later. Okay, let's say you want to learn coding, but you don't really know what you want to build yet, or maybe you want to be able to do a little bit of everything. Then I think JavaScript is a great choice. JavaScript is first and foremost the language that is used in web browsers. So I think 98% of websites out there use JavaScript together with HTML and CSS. HTML is what defines the structure of a website, like where the title is, where the different paragraphs are, images, links, all of this is defined in HTML. CSS is a styling language which makes HTML look better, so instead of just white background with dark text and blue links, you can give it different colors, shadows, rounded corners and stuff like that. And finally, JavaScript is the programming language that makes all of this content interactive. So when you, for example, click a button and something happens, that's JavaScript. When you open a pop-up menu or a modal dialog, all these little interactive effects are coded in JavaScript. And if you want to build web pages, then you have to learn HTML, CSS and JavaScript. There are no other options available. This is what powers the web. Of course, you can learn something like WordPress, where all of this is hidden from you, and technically you don't have to get in touch with the programming languages. But if you want to build quote-unquote real websites, like you want to code them yourself, then you have to learn these 3 languages. But the cool thing about JavaScript and why I like it so much is that you can do almost anything with it. It started as the programming language for web pages, but since then it has grown far beyond that. For example, you can use JavaScript to build web servers using Express and NodeJS, which are basically 2 frameworks that you can download and install and use for free. And This is, for example, what powers the server of my website, TuTab.io. I wrote it in Express and Node.js. It's all JavaScript, and the benefit of this is that I only had to use one programming language for both the front end and the back end, which of course is really nice. Of course, you can also write back-end servers in other languages like Python and Java, but then you have to learn another language. This is why I like JavaScript so much. It's really versatile. You can use something like React Native to build mobile apps for both Android and iOS. And of course, not everyone likes React Native. It has some problems like all cross-platform frameworks do, but the benefit is that you write one single app that runs on multiple different devices. And Instagram, for example, is written in React Native. So if it works for them, then it probably works for you as well. Then for desktop apps, there's Electron. With Electron, you can write an app for Windows, Linux, and Mac like you would write a website with HTML, CSS, and JavaScript. And you can even write games in JavaScript. There are different frameworks for that available. Of course, those are not huge AAA games. Those are just more casual browser games and mobile games. But the point is that if you know JavaScript, you can do so much with it. And that's why I would recommend it to anyone who doesn't really know that they want to do something specifically. They just want to taste programming and try out different stuff. Then JavaScript is a great choice. Now, a big downside of JavaScript is that it is dynamically typed, so it's not very strict in how the language syntax is enforced. You can put any type of value in any variable basically, which makes it difficult to build large apps with it because it's not very robust. It's not a nice foundation to build a large app on. But you can easily get around this by using TypeScript, which is another library or package basically that you install on top of JavaScript. It runs anywhere JavaScript runs, so you can use it everywhere you can use JavaScript, and it adds a static type system to the language, which makes it more similar to languages like Kotlin or Java, for example, which are a bit more strict, which also means that you need to write more code, but the language is much more robust and you can build large projects in TypeScript. TuTab.io, for example, is completely written in TypeScript, the front end and the back end. And I started it with JavaScript, but then I realized that JavaScript was not well suited anymore when the project was growing bigger, and then I migrated to TypeScript, which is something you can do. You can take an existing JavaScript project and step by step migrate it to TypeScript. If you are a beginner, don't worry about TypeScript for now. Just start with JavaScript. A dynamically typed language is a bit easier to learn in my opinion, because you have more flexibility, and you will later realize when it's time to move to TypeScript, and then you can just migrate. So to summarize, JavaScript is a great choice as a first programming language if you want to be able to do a little bit of everything, games, websites, apps, or if you know specifically that you want to build websites, because on the front end it's the only choice you have together with HTML and CSS. And the cool thing about websites is that you can make them responsive with some CSS code, which means that they change their layout on mobile and on different screen sizes. So on desktop screens, for example, they are much wider, so we have much more horizontal room to display the content, but on mobile the screen is vertical and much more narrow, so we need to display the content in a different layout, and you can do this pretty easily with the right CSS and some frameworks that help you with that. And then you basically have something like a mobile app that can run on pretty much any device, because pretty much every operating system these days has a web browser, also Android phones and iOS phones and iPads and so on. And all of these devices will be able to run your website. And if it's responsive, then it will look almost like a native app without you having to write an actual app. This is why I also think web is a good starting choice if you want to build a startup, because it can be used pretty much everywhere. Of course, there are benefits to writing a native app, and we will get to native apps in a moment, but websites are just very versatile in how you can use them. Okay, next let's get to game development. So let's say you know that you want to build games, and even though you can build games with JavaScript, again, those are just more casual browser games and mobile games. The real big games are written in more sophisticated game engines, and two popular ones are Unity and Unreal Engine. A game engine is a development environment specifically designed to help you build games by providing some tools and functionality that they have written for you, so you don't have to write it yourself from scratch. Imagine, for example, how difficult it would be to create a physics system just with raw code. There are so many calculations that have to go in that, and these game engines make it easier for you. In Unity, for example, you can basically drag and drop physics on a game object, then change some parameters in a nice UI, and the physics of this object will change. change, the gravity, the weight of the object, and how much friction it has with the underground, stuff like that. This is the kind of stuff that these game engines help you do. Both Unity and Unreal Engine can be used for free up until a certain revenue threshold. For Unity, I think it's 100k per year. So if you build a game for yourself or a game that makes less than 100k, then you can use it for completely free. And I don't know how much it was for Unreal Engine, but it was pretty similar. They also both let you export your games for different platforms. So these games run on PlayStation, Xbox, for example. So those are real games. That's not like just casual browser games. You can build real games with them. And which of the two you should learn, I think, depends on what exactly you want to do. They can be both suited for beginners, but they are a little bit different. So let's go through both of them in detail. Unity is considered the easier one to get started with of these two. It uses the programming language C#, which is a bit easier to learn than what Unreal Engine uses. On Unreal Engine, it's C++. C# is considered a beginner-friendly language, and also the UI of Unity is simpler than that of Unreal Engine. One of the other strengths of Unity is, especially if you are just alone or a small team, is that they have a huge asset store. The asset store is where you can buy or sometimes even get for free different kinds of graphics, animations, special effects, sound effects, and stuff like that, which of course makes it easier to build your game if you don't want to hire someone to do that, or if you don't want to learn these skills like graphics design. Now, games like Pokemon Go, for example, were written in Unity as far as I know, and also Hearthstone, this World of Warcraft style card game, and Cuphead, which is this 2D platformer game that became really popular. Those were actually written in Unity. So as you can see, real game companies are using these game engines. Those are not just for hobbyists. But the real high-end AAA games with these amazing graphics like Batman Arkham City, for example, or Gears 5, or also Fortnite, which I think doesn't have amazing graphics, but it's a very popular game, were written in Unreal Engine. So Unreal Engine is more well suited for these real high-end AAA games with the best graphics. Now, Unreal Engine is considered more difficult to learn than Unity, and one reason for that is that it uses the programming language C++, which is a bit lower level than a language like C#, which basically means that you get more control over how you interact with the hardware and how you do memory management, whereas a language like C# does all of this automatically for you. But having more control over this also makes it possible to make your games more efficient and just run a little bit better. And that's especially important for these very high-end games that need to get everything they can get out of your system, out of your PC or your console. C++ is also much more popular in the game industry overall. Game engines themselves are usually written in C++ too. So Unity, even though it uses C# for when you program games with it, the engine itself was written in C++ too, and Unreal Engine as well. Unreal Engine also has an asset store where you can get different assets for your game, but I think it's not as big as the one of Unity. So I would summarize that if you want to build smaller games, maybe yourself or with a small team, Unity is a good choice, and it's also easier to learn for beginners. But if you know that you want to work in a real game company where they build these high-end AAA games, then you might be better off learning Unreal Engine right away. And even though it's more difficult, it's still doable. Of course, the learning resources are out there. There are also beginner tutorials for that. Again, you can check out the blog post on TubeTab.io where I link to some beginner resources. So it depends on what your goals are. Okay, next let's get to a mobile development. So again, you could use JavaScript and something like React Native to build apps for Android and iOS. Another popular cross-platform solution is Flutter, for example, which uses the programming language Dart, and it also allows you to build one app that works on Android and iOS. But with these cross-platform solutions, you never have an app that is really optimized for a particular system. So if you already know that you want to build an app, for example, that runs specifically on Android, and you don't care if it runs on iPhones or the other way around, then you are better off building the app with a language that's native to the specific platform, because this way you really get access to all the features the device has to offer, and at the same time you get better performance and usually also a smaller file size than with a cross-platform app. If you don't just build an app that displays some data, for example, let's say you want to use Bluetooth features of the device, then with a native app you can just access this feature on the hardware and it's usually not a big deal. But if you use something like React Native or Flutter, then you need plugins that someone has to write in order to be able to use these platform features, which just makes the whole process a bit more difficult. But again, the downside of writing a native app is that it only runs on one specific platform that you have written it for. It's always a trade-off. The language of choice these days for native Android development is Kotlin. In the past, the only language we had available was Java. Now Java is known for being very verbose. You have to write a lot of code to achieve some functionality. Kotlin is more modern, more concise, and it's based on Java. Now you can still write Android apps in Java, but I would not recommend it for new apps. Sometimes you have to work on older legacy code that's still in Java, so the job demand is still there. But if you are a beginner just starting out, start with Kotlin right away. It's much more popular these days for Android development. And also Google, who owns Android, really pushes Kotlin. All the new libraries and stuff like that are always built with Kotlin in mind first and not with Java. Java is always just an afterthought. For example, Google recently released Jetpack Compose, which is a new declarative UI framework for Android. It replaces the older XML-based layout system we used before, and you can only use Jetpack Compose with Kotlin. There is no Java support. This way you can already see how much Google prefers Kotlin for Android these days. So if you want to getting started with native Android development, just learn Kotlin. And learn Java only if your job requires it. On iOS they had a similar transition between programming languages like we had on Android. There the switch was from the older Objective-C programming language to a Swift. Swift is a language that was specifically created by Apple to build Apple apps. And they also have something like Jetpack Compose, so a modern UI system. For iOS it's called Swift UI. So as the name implies, you write it with Swift code. Now, an important thing to note is that you can only build iOS and macOS and generally Apple apps if you have a Mac, because Xcode, that's the IDE by Apple that you use to build Apple apps, only runs on macOS. It doesn't have a version for Windows or Linux. Of course, there are ways around this. For example, you can run a virtual machine that runs macOS and you can run that on Windows or Linux, but of course this doesn't give you a great developer experience. If you don't want to do that, but you still want to build apps for iPhones, then your only other option is to use one of the cross-platform frameworks that I've mentioned before, like React Native or Flutter. But come on guys, it's 2022, who's still buying iPhones? So next let's get to desktop apps, which I feel like these days is not as popular of a topic anymore, but desktop programming has been around forever and there are many different choices available, probably more than for any other platform. Now you can write a desktop app using, for example, Electron with JavaScript like I mentioned before, but then you're basically building a website that runs like a desktop app. Can be enough depending on what features you need, but of course you get more functionality and better performance if you write a real desktop app. Now one popular language for cross-platform desktop development, so writing an app that runs on Windows and Linux and macOS, is Java, that I already mentioned in the Android section. Now, even though Java is not a popular choice on Android anymore, it's still a popular choice outside of Android because it has been around forever. I think it's more than 25 years old by now and it's really battle tested, and the way Java works is that it runs on a virtual machine, and this virtual machine has versions available for pretty much every major operating system out there, even for macOS, so you can run Java apps on macOS, but not on iPhones. So Java apps will not run on iOS devices. Again, Java is a pretty old language and it's very verbose and it has its problems. But everywhere you can run Java, everywhere you can use this Java virtual machine, you can also use a more modern descendant of Java, like the aforementioned Kotlin. So Kotlin runs on the same virtual machine, which means that you can use it everywhere you can use Java. So you can use Kotlin to write apps for different operating systems. But again, if you know that you want to write your app for a specific platform, then there are better languages available that give you better access to the underlying hardware. To write Windows apps, the most popular choice these days seems to be C# together with .NET. C# is the programming language, and I already mentioned it in the section about Unity here, and .NET is a software framework, and technically you're not writing a native app for Windows this way, because .NET is still a cross-platform framework. It gives you libraries and ways to run your app on different operating systems, but since both C# and .NET were created by Microsoft, it's just optimized for Windows basically. That's why it's such a popular choice to write Windows apps these days, even though it's not a native language. And in fact, .NET is also what Unity, the game engine that I mentioned before, uses to make its game available to different platforms. It uses C# and .NET, and you can use the same system to build normal Windows apps. And as I mentioned in the Unity part, C# is considered a beginner-friendly language. And there are also different UI libraries available for .NET with which you can build user interfaces, like WPF is one, which is short for Windows Presentation Foundation, but there are also other options available. Now again, this is just a guideline, and depending on what you want to build exactly, you might need a different language. For example, you can also build Windows apps with C++, which is especially important in very performance critical apps, where you really need to get everything out of the hardware you can. For example, video editing software, I think, should rather be written in C++ than C#. But as a beginner choice, C# together with .NET for Windows app development is great. Now the recommendation to build native macOS apps is the same as building native iOS apps, so apps for iPhone. It's again Swift, because that's the programming language that's specifically designed to create apps for all of Apple's operating systems. iOS, macOS, watchOS, iPadOS, whatever OS. And lastly, Linux. Now I had to Google this because I've never built a Linux app, but the most popular choice there seems to be C++ as the programming language, together with a framework called Qt. Again, Qt is technically a cross-platform framework, so you're not building an app that's native for Linux, but it provides you with libraries and frameworks to build a user interface, and it seems to be a popular choice on Linux. You could also use the same you use on Windows, C# together with .NET, but again, C# and .NET are optimized for Windows, and on Linux, C++ and Qt just seems to be a more popular choice. Again, C++ is a difficult programming language to learn, but since you use Linux, you're probably a power nerd anyway. And as the last section, my blog post on TuTab covers data science and machine learning. There, Python is a great choice for your first programming language, because Python has many libraries available that work with this kind of stuff. Data analysis, data visualization, machine learning. You can do all of this with Python. Python is a very popular programming language these days. It's usually in the top 3 when you look at these rankings of popular programming languages. It's also considered a beginner-friendly language because it has a very readable syntax. So Python is a great choice as your first programming language, especially if you want to get into data science and machine learning. But you can also use it for other stuff. You can use it, for example, to build web servers, as I mentioned before, or building games. It's also popular for task automation, so you can do stuff like automatically scraping websites, getting data from websites, putting data into Excel sheets. This is also something Python is used for often. And this brings me to the end of this video. Again, don't overthink your choice. Learning another programming language after you have already learned your first one is much easier. And again, you can check out the full post on TuTab.io. I go into a little bit more detail there, and you have this nice overview graphic, links to learning resources and so on, so check it out. The link to the blog post will be in the video description below. And then I hope I see you in the next video. Happy coding, enjoy, and take care.